So, as I stated earlier, the talk that was originally supposed to be in this slot was me talking about medical device security related to insulin pumps. We found some zero-day vulnerabilities in the pump, and we're working pretty closely with the vendor, and they needed some more time for the disclosure. So we pushed back by 2 weeks to help them with that. And so you'll find out about a lot of the details related to that in 2 weeks. But some of the technology that I used and some of the techniques I used came directly from my experience in radios. So when they asked me, well, do you have another talk that you could give, even though it's only 5 days away? I said, well, I guess I could give a talk on some of this ham radio stuff I want to do. And they said, yeah, that'd be great. So this is something I whipped together in the last 5 days. I have no idea if it's going to take the entire hour or if it's going to take 3 hours of material here. But it's kind of an idea that I've had for a while to give at a conference, which is I've been a licensed ham radio operator since I was a kid. And a lot of the techniques and things that I've learned in that hobby are things that I use in my information security career all the time. So I wanted to kind of compile them and show what things in that hobby and the ideas that you learn in that hobby can be used in a practical application in the security world. So this is me. I asked my dad for a picture of me taking apart stuff, and this is what he sent. And I've always been that kid. I've always been the kid taking things apart and trying to figure out how they worked. And from an early age, ham radio has been kind of around and part of my life. My dad's a ham radio operator. His brother is a ham radio operator. And the idea of ham radio operating to me is kind of second nature. And there's a lot of controversy over like how the name ham radio came to be about. But basically, ham radio operators are hobbyists that play in the radio community. And you get an FCC license, and you're allowed to use radios at certain powers at certain frequencies. And there's been a lot of great talks about what things you can do in ham radio and what it is to get licensed that I'm not going to cover. Because I want to talk to you about some of the things that goes on after you get a license, which I haven't seen covered too much in a lot of these talks. So where does my story start? Well, this is my dad, quite embarrassingly, probably drinking at the kitchen table with a soldering iron, putting together or fixing something. And he, ever since I was little, has been exposing me to the world of hardware and electronics. He's done computer programming, he does hardware programming, and overall has been a great dad and a great mentor to me. Even to this day, when I run into problems, when I'm reverse engineering a protocol or doing RF stuff or even code, I'll call my dad and to get advice and to get a different look at things and how things work. But in the summer of 1988, we were at the very peak of the solar spot cycle. And when you're at the peak of the solar spot cycle, it's probably the most exciting time for amateur radio operators because it means that you don't need very much to talk all the way around the world. And I vividly remember that my dad had this exact radio in his car. It's a 10-meter radio that you can use it for CB radio as well, but it puts out only 10 watts, and he had a little mag mount antenna that he stuck on the top of his car. And I would remember going out and sitting in the car and listening to these stations that were all over the world. They were in South America, they were in Cuba, they were in Europe, Australia, and there was nothing between me sitting in this car and that other person on the other side of the world. And I think that that's something that's lost in today, that magic. We just kind of take it for granted that we can spin up an email, send it off, and it gets wherever it's supposed to go in half a second. In '88, this was crazy. Like, it's crazy that I could do this with a radio and a piece of wire off the top of my dad's car and hear and talk to these people. And instantly, that magic is what really had me hooked. So first, to play in the game, you gotta get a license. And back in '88, the licensing requirement still meant that you had to learn Morse code. And this was a really controversial thing, right? So for the very first test, you had to pass 5 words a minute. Ooh, ooh. So this is what 5 words a minute sounds like. Now, at this speed, you could think of it and you could probably look it up in your head. All right, dash, dot, dot, all right, that's D, and something like that. So it's pretty easy. The bar is pretty low to pass that. As you advance through the licenses, they get harder. So 13 words per minute is the next one, and that's what this sounds like. It starts to speed up. It becomes not as easy to look up in your head. At 20 words per minute is the most advanced license you can get, and that's what this sounds like. So those are the three classes. Now, since then, they've removed all of the Morse code requirements for the licensure. But back in my day, and this is something that ham radio has in common with the security community, is there's a lot of people that are back in my day people. Real hams did CW. Real hams did Morse code. Real security people use the command line. Very similar methodologies between those two. Along with this code test, you took a multiple choice test that's very technical. You just kind of study for it, memorize the questions. It really wasn't too bad. At 12 years old, I passed the license, and you get a call sign. And that call sign is unique to you, and it's how you identify yourself on the air. And my first call sign was N8RHV. And that first part there, the N part, signifies what country you're in, and the 8 is what section of the country you're in. So you can tell by a person's call sign where they got licensed from originally. This is the very first radio I had. It was given to me as a gift by my uncle. It's a 1970s handheld radio. It only covered 4 megahertz worth of bandwidth. It was heavy. It used NiCad batteries. I could probably knock somebody out with it. It was a great little radio. And back in those days, they were several $100s. And that was really cool. It was a great gift to have. It was, I have very fond memories of it. Now, the first passion that I had with radio and ham radio stuff is actually in packet radio. Now, packet radio was this concept, and hopefully it sounds familiar, is you take 2 computers and you make them communicate with each other digitally, and they can exchange information. So, through a combination of things, through the HT and the computer, I was able to load a program called NOS, Network Operating System. And this NOS thing had a full list of this TCP/IP thing. And with TCP/IP, I could communicate and get my own IP address, because there's an entire class A set aside for amateur radio communication, the 44net. So you can see up there, that was the IP address that I got back in 1989. And I was able to set up a station with that IP address that was able to do mail, that was able to use ping. Finger was another command that we used quite a bit. You have to remember, this is way before HTTP, way before web browsers. And it was also slow. It was 1200 baud half duplex. So I could only talk or listen. I couldn't do both at the same time. So to give you an idea, silly thing, give you an idea of what that sounds like. That is the first part of a TCP handshake. That's what it sounds like. Also with this program, what was kind of neat is if you hit F9, you could see all of the packets that could be heard on that frequency. That sounds kind of familiar. It was exactly like Wireshark is, or TCP dump. I could see the headers, I could see the TCP, all the TCP fields, and at 12 and 13 years old, I was kind of figuring out, okay, this is how the packets were structured, this is how they were talking. And it was really fascinating to play with this type of technology. Now, one of the things that was kind of neat, I lived way up here. My call sign now is N8OS. I lived in the Detroit area, and there's a gateway down at Wayne State University, 21.1 miles away. And that gateway went from radio to the internet, because Wayne State, back in the late 80s, was, colleges had internet connection. So I couldn't quite get my signal all the way to Wayne State. So what I ended up having to do was I had to talk to a friend of mine. and I would route all of my traffic that needed to go to the internet to there. Also sounds very familiar to what maybe we do these days with routing. And I set my default route to that. So if I couldn't communicate with something directly, it would go through that person. Or maybe if I was going north of me, there would be another route that I would take differently. In these programs, you had to set all of these routes by hand. So you were manually making routing tables to figure out how to route packets all over the place. And collectively, back in the late 80s, early 90s, you could get all over the United States purely on wireless, with the wireless connectivity that goes around. Now, since then, that's kind of a little bit fallen off the wayside because everybody's got high-speed internet at home. But it's starting to make a comeback that we'll talk about a little later. But the skills I learned in packet radio were, I learned how to read my first packets. Everything was going so slow that I could actually, I remember laying in my bed and listening and saying, oh, that's a handshake, oh, that's a piece of email coming in, just by how long my transmitter was on and how I could hear it, because of how slow the data was being transmitted. So if you were to slow down a TCP handshake and listen to it, you could do that at that speed. And building routing tables is something that, that became second nature. But you know what? I really didn't want to depend on somebody else to get down to that ham gate. I wanted to have a direct internet connection. So how do I do that? I'm 12 years old. I need to build an antenna is what I need to do. Now, I don't have any money because there are child labor laws. And my dad's not going to buy me an antenna. And hams have a long history of building stuff out of garbage, of taking things apart, taking junk and building something else. So I built what you see up there on the screen. I got a broken hockey stick, some dowels from the hardware store, some leftover wire from a construction site, and a 20-ounce pop bottle. And with the knowledge that I had from passing the tests, I was able to build a cubicle quad. And with that, I was able to easily talk down to that ham gate and directionally move the antenna to talk to other people. And this was pretty cool. I was so bummed when I would start looking for pictures this week because I was like, Dad, why didn't we take pictures of any of this stuff? He was like, you mean that junky antenna that you built, that you stuck on top of your bedroom? I was like, yeah. He was like, I never thought you would need a picture of it. And I was like, I really wish I had a picture of it. So this is as close as I could get. But it's really kind of cool. And like I said, there's a history of this, and hams love doing this kind of stuff. How about an old beat-up lawn chair that doesn't work anymore? Right? Very easily, this guy took this aluminum-framed lawn chair and built an antenna out of it. How about a broken tape measure? Broken tape measure and a couple pieces of leftover plumbing material, PVC, and you have a very accurate, high-powered antenna. The thing that I learned here is that knowledge is more important than commercial tools. Right? You can go out and buy any kind of commercial tool you want, but having the knowledge on how to build things on your own, whether that is an antenna or shell script or whatever it may be, sometimes is better because you actually have the knowledge on what it is and how it's working, as opposed to just taking it out of the box and sticking it and hoping it works. You can build things that you need and be creative. I mean, I think that that's part of having fun. You know, and I've always thought of hacking as taking something that has a function and making it do something that it was never intended to do. Like this slinky. This is one of the more popular antennas to build, is you get two old school slinkies and you can make an antenna out of them. And taking things and making them do something else, whether it's a program, whether it's a website, whether it's a toy, and making it do something else is a lot of what our security field is and about how we think about it. So on the next thing of building things, I got into kit building. And this is something that has become a lot more prominent and a lot more useful as we have gotten into hardware hacking, and that's become an Internet of Things, take things apart, look at the circuitry. Well, I would build kits. Here's an example of a kit that I built. It's just a bag of parts. You've got to get a soldering iron and learn how to read a schematic and know where to put the parts in. So I could remember as a kid sitting with my dad at the kitchen table, building things like this, learning how to solder, how to troubleshoot things when it didn't work, and it never did the first time you tried to build it. It's really the foundation of hardware hacking. And the history of kits for ham radio operators goes a long way back. This right here is probably one of the most famous kit companies that there was, which is Heathkit. And Heathkit was based out of Benton Harbor, Michigan, and they made tons of radio kits. This one right here being one of their most popular, which is a 2,000 watt amplifier. You could buy this for a couple $100 back in the 60s, and they are still in use and quite popular because they don't die, and they're easy to repair, and they're worth quite a bit. So these kits have so much documentation, and you learn so much by building them, that it really produced a great foundation for learning electrical theory and learning how to build and take apart things. Now today, they're a lot more advanced, but they still exist. This is the most popular kit company right now. It's Elcraft, and they're based out of the Pacific Northwest. And they built, this is kind of their flagship, this used to be their flagship radio, but this is a kit that you can build. And the kit looks like this. That circuit board, you have to put all the parts on it. So you have to solder it together, and you have to align it. And it's a process that takes about a month to build that radio. But at the end of that month, you will have built a radio. And you will know how to tune that radio, and you will know all of the pieces and where the amplification section is and where the oscillators are. And that's kind of neat. That's kind of an exciting prospect. We don't get a chance to do something like that where we build something from scratch. And it's always a fascinating process. And because of that, these kits are extremely popular. The skills I learned there are, this is the foundation of all the hardware hacking that I do. When I take apart an insulin pump or a medical device or an Internet of Thing or whatever, it's just like being a kid again. It's soldering, it's unsoldering things, it's trying to make it work, it's trying to make it do something it wasn't supposed to do in the first place. Also being able to diagnose and troubleshoot hardware. Oh, well, I know that if I don't have the ground set up right, that this isn't going to work, or it's going to act like in this way. I also think it's neat to build things. The hacking community as a whole has really gotten into a making community with 3D printers and Arduinos and Raspberry Pis. And these two areas really mesh well together in learning how to read a schematic and build those type of electrical circuits. I'm going to talk a little bit about some of the radio sports, and these are competitive features of radio. So one of the first that I participated in as a teenager was something called fox hunting. And fox hunting is the sport of finding the physical location of a transmitter. You got a picture up here of some kids with a directional antenna, very similar to the one built out of the tape measure I showed you earlier, and they're working on trying to find this transmitter. The transmitter could be really small, like it could be hidden in a tree. It's usually battery powered, it's usually maybe the size it would fit in your hand. So you use directional antennas to determine the source of the signal, and then you try and track it down. And they have competitions for how quickly people can find it on foot, or to find it in a car. And this is a really kind of a practical thing, because if you have something interfering with a radio signal, or maybe interfering with a wireless network, you need to be able to track down the physical location of that transmitter so you can do something about it. Also, we get back into this creativity element. This is something that my dad and I had built one of these. This isn't the exact one because, again, we didn't take pictures of the junk that we made because why would we need pictures of it? But this is a Doppler unit. And what this is a small microprocessor would switch between 4 antennas, and the Doppler shift in the signal between the 4 antennas was able to calculate the direction and the heading of the signal. So we could have this strapped to the top of the car and drive, and the LED would point to the direction of where the transmitter was located. And that's something that we built from scratch on our own, which was kind of cool. The skills I learned here, I learned a lot about wireless signals and wireless networking, how signals get manipulated by physical structures. As you get more advanced into fox hunting, they put the transmitter in sneakier places, like up against metal buildings or near power lines. And it becomes really confusing when the signal gets picked up by those power lines or bounces off of buildings. Not all that much different than wireless networks and how we map a wireless network. But also, it was fun. Like, it was, the way that they set these up were really tiny things, and you were going and hunting around for them. It felt very spy-like. So, as a teenager, I thought it was a blast. It was like treasure hunting. One of my passions really became contesting as a radio sport. Contesting is a sport where you try and make the most amount of contacts in a set amount of time, and you exchange the information accurately. This information could be very simple, like what state you're in and how much power you're running. Or it could be complex. It could be your name, a unique serial number, the first year you were licensed, the county you're in, things like that. So there's a 12-hour, a 24-hour, and a 48-hour period that they might have these contests where you try and contact as many people as possible. The most popular methods of contesting are voice and, surprisingly to some, Morse code, which is referred to as CW, or continuous wave. The rates for how quickly you can make contacts at a big station can exceed 200 contacts an hour, which is a lot of information. And the reason that these contests became popular and have been kind of used throughout the years is this is how you prepared for an emergency. If you needed to pass a lot of information to, let's say, the entire phone system went out, or all the power in the United States went out, how would we exchange messages? Well, we could use radios to do that. And we could use radios to exchange this information accurately and effectively all over the place. I had a wonderful opportunity to work at what I would refer to as a superstation, which is a station that has a lot of antennas and a lot of investment equipment in order to compete at a very high level. So this is one of the superstations that I didn't operate at this one, but I operated at one very similar. So each of those towers are probably 160 feet tall, and each of those antennas are at least 40 feet long. So right there you have enough antenna, you probably have $500,000 just in antenna equipment there. And then each of those antennas are hooked up to radios, usually in some kind of a bunker or house nearby there. And it's pretty cool to see that kind of a setup. This is actually the setup that I worked at in Ypsilanti, Michigan the guy's call sign is K8CC. And he has 4 different antenna arrays, and his entire basement is radio equipment. And he's invested a lot of time in competing at that, and he has records for the most amount of contacts in some of these contests. To give you an idea of the scale of some of this stuff, I mean, those are the 2 people up there working on the antenna arrays. Those are big antennas. They're giant. This is the rack of amplifiers, and all of those amplifiers put out 2,000 watts apiece, and they're all hand-built. So the creativity and the amount of knowledge that you need to build this type of equipment is pretty excessive, and also to not interfere with the other stations that are right there 2 feet away. To give you an idea what a contest sounds like, I've got 2 examples here, a voice example and a CW example. So there's only 30 seconds in each of them, so hopefully you can hear it. No. Where's that? Kilowatt 5 Tango radio.
Kilo Fox 6 Tango.
Kilo Fox 6 Tango, 59176.
Roger, 5916.
Thank you. Kilowatt 5 Tango radio.
Kilowatt 9 Tango radio.
Kilowatt 9 Tango radio, 59177.
USL 59 number 020.
Thank you. Kilowatt 5 Tango radio.
03 Tango Whiskey.
K3TW, 59178. So you can see he's working those stations. He's exchanging information, you know, and a unique serial number and getting it back from them. But you can also, it's a little hard to hear. those radio stations are calling 3 or 4 at a time, and he's able to sort those out in his head just by listening at a very quick rate, which is impressive. He did over 21 contacts here in 3 minutes. In CW, you can go even faster. Most of the really good high-end contest operators prefer to do CW. Where is the play button? There it is. So that's just 2. So it's kind of a unique way. I've always been amazed at the people that can sit with headphones on, listen to that, and be like, oh, they can have a conversation with me, and decode that in their head, and type in the station and serial number, and just work people. And I'm like, huh? Like, that's never been anything that I could do. I've never been a master at the Morse code portion of this. So it's neat. Now, just about everybody has their first contest experience with the same contest. And it's a special contest referred to as Field Day. And Field Day is special because the object is to start with an empty field, with nothing. And in 24 hours, set up a station. And that station needs to operate for 24 hours, and you make as many contacts as possible. And you get extra points for using alternative power and doing it in public locations. And the object here is to simulate a very realistic scenario, whether it be a hurricane, a tornado, a terrorist attack, where you lose all communication. And then you set up a station to communicate all over the United States and exchange that information. And it's really popular because everybody can participate in it, because everybody's kind of starting from scratch in an empty field or in a park or at their house. But you're not allowed to use any existing antenna structures. So this is an example of like a field day setup. They went out into the woods and they put these antennas up in a couple hours. And they're going to operate for 24 hours and exchange information all over the United States. You know, we'll talk a little bit about CW and Morse code to give you an example, to give you an idea of why it's still really popular, is that it's the original digital mode. This is how we send ones and zeros. It's on and off keying, which is used in a lot of Internet of Things transmitters right now. And it's exceptionally efficient. You can see on this slide, there's a lot of signals. There's a lot of people transmitting Morse code here. But the amount of bandwidth that this is using is minuscule. It's 0.007 megahertz worth of bandwidth. To give you an idea, your wireless 802.11 signal is usually 20 megahertz wide or 40 megahertz wide. So this is not even a dot on that spectrum relative. And we've got at least 20 stations communicating to each other effectively here. So it's really an efficient way of communicating in a pretty good amount of information. One of the big things that amateur radio has gotten into in the past, it's always been a big part of amateur radio, but especially in the past 10 years, is emergency communication. And they have a slogan that when all else fails, that amateur radio is there. We have become totally and completely dependent on cell phones, on the internet, and on that technology. And what happens when it stops working? We've had situations where it has, in hurricanes, in third world countries, where amateur radio operators were able to stand up and start communicating statuses and coordinate rescue efforts within hours and sometimes less. So a lot of amateur radio operators are very proud of their commitment to emergency communications and being able to respond in disaster situations like that. The skills I learned here, I learned a lot about disaster recovery. When we advise customers on, when I advise customers on disaster recovery, I talk about testing. And I talk about, well, what's going to happen when your phone stops working? And they go, oh, what's the chances of my phone's not working? And I realistically know that that's a possibility. Do you do disaster recovery planning? Have you tested this equipment out so that it works? One of the reasons that field day is popular is because it's every year in June. It gives you a chance to test out all your kit that you could take into the woods and set up a station if you had to. And that testing this stuff only works when it's tested completely and it's done often. Passing traffic and messages and all forms of communication are down is something that's really important. How do you do that at your company? If something were to happen, we saw that happen with Hurricane Sandy when it came through on the East Coast. Does your disaster recovery plan have the ability to communicate when other forms of communication are down that you can't text? How do you find those people that are in your disaster recovery plan? It's important. I also learned about building incredibly complex radio systems with lots of transmitters at high power. And that's been very handy for things like devices that communicate with wireless signals, that maybe you exchange data with cell phones or medical devices. I'm going to go over a couple of other areas that I don't have a ton of experience with, but are definitely big in the community. The first is there's a lot of space stuff that goes on. There's a whole section of the hobby that builds satellites. The thing that you see on the far right-hand side is HAMSat-5. It's a satellite that hobbyists built, that NASA put in space, that orbits outer space. And the picture on the left there is a little girl and a guy working that satellite with that antenna that he's holding and a small handheld radio. I mean, just imagine that. That's a radio that puts out 5 watts of power that's no bigger than your cell phone, and it's talking to a satellite in space. That's pretty cool. A lot of the astronauts in the ISS space station are amateur radio operators, and they do a lot of operating from the space station. So there's often classrooms that get to talk to them through amateur radio and through ham radio connections. So there's a lot going on in the space world with amateur radio on a hobbyist level. Now we can talk about some even crazier stuff, right? This is called a moon bounce array. And what this is if you get enough antennas and enough power and you can see the moon, you can bounce a signal off it. So maybe I can only talk 10 miles with my little handheld radio. On the same frequency, with this antenna array and a whole bunch of power, I could talk from here to Europe if the moon's in the right spot. Wow, that's kind of crazy. That's hacking, right? Let's bounce some stuff off the moon, and we can get much further signals. How about meteors? Meteor scatter is something that we can use quite a lot on different things. So if we know there's a meteor shower, we can go thousands of kilometers between 2 stations, where normally we wouldn't be able to do that. By aiming our signal at the trail of the meteors, or where the meteor shower is happening, and bouncing the signal off of that. These are some of the crazy things that you can do in the hobby of radio. And to me, this is like classic hacking, right? Like, that's crazy, you can't do that, there's no possibility that'll work. Well, I want to try it anyway. There's a huge group of enthusiasts that really love the low power aspect. They want to see how far they can go on as little power as possible. QRP is kind of a slang term for very low power, usually under 5 watts. The record, as it sits right now, from what I was able to find, is 2 stations between Alaska and Oregon in 1970 were able to go 1,650 miles using 1 microwatt. And so that is the equivalent of 1.6 billion miles per watt. That's crazy. Like, and that's very similar to the transmitter that they were using, is what you see there. They build it in an Altoids tin. It's pretty creative stuff. Morse code has been actually increasing in popularity since they got rid of that requirement in the license test. I don't really know how to explain it. People are very competitive with it. The speeds can get in excess of 200 words per minute. I mean, you saw how quickly that was, and that was roughly around 30 is about how fast you've heard some of that stuff. 200 doesn't really sound like anything human. It sounds more like aliens. Contesting people often 30, 50 words a minute is usually where they kind of hang out at speed-wise. Again, they do it all in their head, conversationally. Going back to like community stuff, public service is another big piece that ham radio operators do. They have clubs, and these clubs will get together and they will provide communication for parades. They'll provide communication for athletic events like marathons, like triathlons. Here you see one that my dad was participating in the state of Michigan, where they were doing communications like for a bike ride. And this gives the ability for them to be able to communicate if somebody got hurt, if somebody needs to get picked up, those types of things. We think that cell phones would be great for that, but when you get out, we know how great cell phone communication works when you're out in the middle of nowhere. This is a much more reliable method. Another area that's always been popular is collecting what are called QSL cards. And QSL is ham radio slang for a verified communication. So a lot of ham radio operators will have a card, a little postcard, and they'll say, yes, I'm confirming that I talked to you at this day, at this time, with this information. And you collect these cards, and you can get awards for these cards. So there's a Worked All States award. There's a Worked All Continents award. There's a Worked All Countries award, or Worked 100 Countries award. So you collect these cards, and you can put them on your wall, and you can see, oh, these are all the places that I've talked to through my radio station. And it's been a very popular way to collect them. As we've gotten into the digital age, this has turned into EQSL cards. And there's several sites that specialize in matching this information up, and automatically, instead of mailing a postcard, now we do that digitally, verifying that we heard and communicated with this other person. We're also seeing some recycling here. So this is an older Linksys router, and ham radio operators are starting to buy up some of this equipment and modifying the firmware and building entirely independent off the internet networks that are high-speed multimedia mesh networks. So because amateur radio operators can use more frequency and more power and larger antennas, they're buying this equipment, modifying the firmware, and then building their own ISP. They're building their own wireless infrastructure to communicate. Almost exactly like we were doing in the 80s, except for not at 1200 baud half duplex, which is pretty cool. And it's a great way of repurposing, going back to that original kind of methodology and concept of hackers taking things that are other people's garbage, repurposing them, and making them into something that's extremely useful. So, where am I using all these ham radio skills now? Well, at 900 megahertz is what we call the ISM band, or the Mike's band. And this is used quite a bit in the medical world. A lot of medical devices communicate on this band. They're designed to be very short distance. So maybe only 10 feet is how they're supposed to communicate. Like if you had a pacemaker or an insulin pump, that's what they designed that effective range to do. But as we've talked about, we could build antennas and get much further. We can use higher power, and we can get much further and communicate with them. We also have a lot of equipment in the world, especially in the power grid world, that runs at 400 megahertz, which is also right near a ham radio spectrum. This goes back again to we can build antennas, we can do things to communicate with them in ways they weren't intended to be communicated with. How about RFID chips? Those run at 13 megahertz. A lot of those contest superstations, the pictures that you saw in there, those amplifiers and that equipment would work on the RFID of 13 megahertz. What could I do with giant 160-foot towers and 2 kilowatts of power with an RFID? How far could I talk to it? I don't know. And obviously, software radio has become really huge. Now that we have so much horsepower in our computers, we can do a lot more with software than we could in building. And we can hear farther and we can process more in that time. HackRF1 is a great example of that. In the last several years, these have come to be $200 and are heavily used now in the hacking community, in the Internet of Things, in the hardware hacking world. So here's an example of some work. So this is a Yardstick 1, another tool that's similar to HackRF, and it puts out 0.01 watts. But at a ham radio convention, I bought an amplifier, and that amplifier will make that into 100 watts. That's a pretty substantial increase in power. I'm licensed with my FCC license to go up to 1,500 watts if I want to. But 100 watts will be enough for now. Now, for every 3 dB of increase, that's like doubling your power. So I bought some antennas that you can see here in the pictures that double and triple and quadruple the amount of power. But not only that, they quadruple the amount of listening that I can do. So I can listen further with these types of antennas and in a single direction. So, what's possible? Well, that's a great question. What could you talk to with 10,000 times more power and 8 times more listening capability? That would be in the medical world. How far could you get? Or in the smart grid world? Or in the Internet of Things world? These are the kind of cool things that I like to work on and do research on. Because I don't know. I don't have a lot of the answers to those questions, but I have a lot of fun doing this type of stuff and using my hobby and using the 25 years I've been doing ham radio stuff to play around with medical devices. And to say, when people come up to me and say, well, you can't talk to that medical device, it's more than 10 feet away. And I kind of smile and I think, we can bounce a signal off the moon at almost the same frequency range, and I can talk to somebody in Europe. I think I can get a quarter mile away. I think I can get a half a mile away. I don't think that's going to be a problem. And that's surprising to people. But hams have been doing this for decades, have been pushing the boundaries on what's possible. And that's something that's really exciting, and they still continue to do that today, on taking things, taking other people's garbage, things that are disposable, and reusing them, very much like a hacking culture would. So that is what I have. I want to thank you guys for coming, and I hope you enjoyed it. Oh, yeah. Sorry.